So when you're multiplying polynomials, and this is considered a trinomial because it has three terms, so tri meaning three terms, 1, 2, and 3, and we're going to multiply this one by a binomial, referred to a binomial because it has two terms, so we've got 1 and 2. You can think of it the same way you do if you're multiplying a 3-digit number times a 2-digit number. So when you do something like this, notice the 3-digit number 324 is really 300 plus 20 plus 4. So that's kind of like three terms, 1 here, 2, and 3. And then you're multiplying that with a 2-digit number, 23, which is like 20 plus 3. And so you could imagine how the structure that we use over here in this problem is going to be very similar to the structure that we can use in this problem, where we've got three terms, 320 plus 4, just like these three terms. And I'm going to use that same kind of idea. The 20 plus 3 is like the 3x plus 4. And so I'm going to use the same logic for multiplying polynomials that I do when I multiply multi-digit numbers. And that's stacking and using the different columns to figure it out. So normally when I do multi-digit multiplications, I'll put the one with more digits up on top, like I have here, and then the one with less digits on the bottom, like I have here. And then I'm going to multiply these together, and typically we start from the one furthest to the digit furthest to the right, or the term furthest to the right, and this particular digit or term gets multiplied by each of the digits or terms of the top thing. So essentially what I'm going to write in this line is the result of taking positive 4 and multiplying it by 2x squared minus 5x plus 3. So I'm going to start with the 4 times the 3, and that gets me a positive 12. Then I take the 4 times the minus 5x, and that gets me a minus 20x. And then I take the 4 times the 2x squared, and that gets me an 8x squared. And so that first row is what I get when I multiply the 4 from this bottom times each of the terms on the top. Now, just like when I'm stacking and multiplying multi-digits, I'm going to move on to this next digit, which is my 3x, and I'm going to change colors here for us. So the 3x now will also need to get multiplied by each of the digits or the terms of the top thing. So my 3x is now getting multiplied by each of the pieces of 2x squared minus 5x plus 3. And that's what's going to end up in this row. Now, when we're doing it with numbers, typically we put a 0 in this first column because we'll end up with 0 ones, because the thing we're multiplying is a tens place. We don't have to do that here, but it still benefits us to put things that are like terms in the same columns. So when I take the 3x times the 3, I end up with 9x, and so it makes sense to put it in the column where the x terms are. And because it's positive, I'm going to put a plus sign out in front of this. And then the 3x times the minus 5x would get me a minus 15x squared. Remember that the x times the x gets you an x squared. And then finally I have my 3x times my 2x squared, and that's going to get me a 6x to the third, because I'm taking x squared times x's. So now, just like with your multiple digit multiplications, we're going to add like terms. In numbers, we add the ones place and the tens place and the hundreds places. Well, here we're adding constants with constants, and x's with x's, and x squareds with x squareds, and x to the thirds with x to the thirds, and we're getting a final answer. So in this case, I'd get 6x to the third minus 7x squared minus 11x plus 12. So what we just did here was we stacked them and then multiplied down, and so this is sometimes referred to as stacked multiplication, or another way to think of it, another way that it's referred to as, is vertical method, because it is being multiplied vertically downwards when you're figuring out those products. So this is one, we'll call it method 1, this is one way to complete the multiplication of a polynomial with another polynomial. It doesn't matter how many terms it has. In this case, we had 2 times 3 terms.